First, we're going to check Wednesday's daily math. You're looking on the first one for the model that correctly represents the problem. So we're subtracting fractions. When I add or subtract fractions, what do I have to always check first, Olivia?
The bottom number.
The bottom numbers. I have to make sure the bottom or the denominator is the same. And they are in all four options. So I know that I don't have to find any equivalent fractions because my denominators are already common. They're already the same. So let's look at the first one. We have 11/12 minus 9/12. So since we know that the denominator's the same, all we have to do is subtract the numerator or the top number. Is 11 minus 9 equal to 5?
No.
No. So 11/12 minus 9/12 is not equal to 5/12. Let's go to option 2. 11/12 minus 6/12 equals 5/12.
Yes.
My denominator stays 12, and 11 minus 6 equals 5. 11 minus 6 is 5. So we know that the math is correct. Let's look at the model. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces shaded. They crossed out 1, 2, 3, 4, 5, 6 of those pieces. And it shows that there are 5 pieces left. So is that the correct model? What's wrong with option 3?
It has just 3 things that are clear, not 5.
Yeah, instead of taking away 6.
They took away literally
8.
Yeah, they took more than what the model showed. Or more than what the problem showed in the model. Okay, questions on that one? All right.
I got 10 out of 10.
I got 10.
So the next question asks us, what is the length of W? What do we know about this rectangle? What's one thing that we know about this rectangle, Christopher?
That the area is 75 meters and that there is 15 meters on the bottom.
All right. So how did you know that the area was 75 square meters?
Because it says A in the middle.
Yeah, in the middle it says A, and we know that A stands for the area. The length is what, Scotty?
And it's 15.
The length is 15 meters. They give us that. So how are we going to find the width? What are we going to do, Jacob?
You can divide 75 by 15.
Yeah, if area equals length times width, we know the area is 75. We know the length is 15. So we're looking for 15 times what number equals 75? Or we could turn that around and do 75 divided by 15. So what is the width going to be, Cash? Okay. How did you get your answer? What did you do? Okay. So we could multiply 15 times 5. And if I do that, I would get 75, which we know is the area. So that tells us that our answer checks out. The correct answer was 5 meters.
It said that I got 8 meters yesterday. I did 5. I got
Because I chose 5 and then it said that it was 8.
And I'll go back and look at it.
I had this breakfast
Okay.
that
Let's look at this next one. It says to complete the missing information for the equivalent fraction and the decimal form of the fractions. So 8/10 is equal to how many hundredths? How many hundredths does it take to make the same amount as 8/10? Dylan?
80.
80. A is equal to 80. Okay, so now we need B. We have to put 8/10 in decimal form. How do I show 8/10 as a decimal? What do I need there, Ansley? Very good. 0.8. I would have an 8 in the 10th place. And then how would we show 80 hundredths as a decimal, Harper?
Point on 80.
Very good. 0.80 or 80. Have 80 hundredths.
Can I do number
That's
5?
Okay. All right, let's look at this next one. We have some decimals to compare. So we've got to look and see which one is modeled correctly. We've got to make sure that the model matches the decimal and that we have the correct inequality symbol. So the first one, we have 75 hundredths is less than 6/10. Do we have 75 hundredths shaded?
Yeah.
Yeah, I can look. I've got 10, 20, 30, 40, 50, 60, 70, and then 5 more. So that's 75 100ths. 6/10. I have 1, 2, 3, 4, 5, 6 of the 10 shaded. Is 75 hundredths less than 6/10? No. I can see that I definitely have more shaded with 75 hundredths. All right. The next one says 75 hundredths is greater than 6/10. So we know that part is true. Let's check the model. Is this showing 75 hundredths? That's showing 7/10. I'm sorry, 6/10, not 7/10. And on the other side, it's showing 75 hundredths, not 6/10. So we know that those models are incorrect. Okay, how about model 3 or option 3?
Yes.
75 hundredths is greater than 6/10. We know that's true. Do we have 75 hundredths shaded?
Yes.
Mm-hmm. Do we have 6/10 shaded?
Yes.
Yes, so option 3 is the correct answer there. What's wrong with option 4?
Then it's messed up because the numbers, it says 0, it says 10, it says 0.6 on the 75, and then it says 0.75 on the 6.
Yeah, they've got the model mixed up and the inequality's wrong too. Everything's wrong about that one, isn't it?
It's just different.
Okay. All right, number 5.
Can I do this one?
You have fractions on a number line. What size pieces is our number line broken into, Christopher?
5. Wait. Yeah, 5.
It's broken into fifths. Between 0 and 1, there's 1, 2, 3, 4, 5 equal parts. So what does A represent, Christopher?
2/5.
A represents 2/5. What does B represent, Dylan?
3/5.
3/5. How about C, Amy? 4/5. What does D represent, Olivia? 5/5. But 5/5 isn't one. Oh, 5/5 is one of our options. It didn't change it on here.
Yeah. That one was
easy.
That one was an easy one. What if instead of 5/5 here it said 10/10? Would that be true?
Yes.
Yeah, because that's still one whole, isn't it?
Yes.
Yes.
And we know that D represents one whole.
Yep.
All right, questions on Wednesdays?
No.
All right.
You could also do
All right, let's go to Thursday. Which model best represents the answer to this problem? This time we have mixed numbers. We have 1 and 5/8 plus 1 and 2/8. So when we're adding mixed numbers, what are we going to do with these two whole numbers?
add them together.
We're going to
make
add
3.
them together. And what about the fractions?
You add them together.
We're going to add them together. So we have 1 whole plus 1 whole. How many wholes do we know we'll have?
2.
2. 5/8 plus 2/8. My denominator's the same, so I can just add, and that's going to equal what, Olivia?
7.
7 what?
8.
What's my denominator? 8. So I'm looking for 2 and 7/8. Which one is that, Jaden?
I wouldn't really correctly understand this one, but it's either the second one or the first.
Which one shows 2 and 7/8?
I know.
Okay, well here's 1 hole, 2 holes, and then if I count the 8 size pieces, I have 1/8, 2/8, 3/8, 4/8. So option 1 has 2 and 4/8 shaded. Option 2 has this whole thing is shaded and this hole is shaded, so there's my 2 holes. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. So option 2 shows 2 and 7/8. If I look at option 3, what is option 3 showing?
It shows the same, but the bottom is all the ones on the bottom are X'd out.
Yeah, it started with the same amount, but they crossed out all of the 7/8 at the bottom. So all that's left is 2 holes.
Option 4 is the same, but the top is.
Yeah, option 4 has 2 and 7/8 to start with, but they crossed out 1 hole, so we have 1 and 7/8 left. So which one's the correct answer?
Option 2.
Option 2 is correct. Do you see why, Jaden?
I got that one correct, and it was just I
Wait, isn't
So
the
do you
next
understand
one,
now? You would be able to answer that tomorrow.
Isn't the next one the triangle?
Yes.
And next we have
Wait, no.
an angle.
I think the angles are kind of hard.
Oh yes.
All right, so let's look at this angle. It says if angle LMN is 90 degrees, so from point L to point M and over to point N, that makes a 90-degree angle. What is angle PMN? So we know this is 90. From P to M to N, we have to figure out what that missing piece is. So how am I going to figure that out, Cash? What do I need to do?
At the end to get to 90, I added 15.
Okay. So you did 75 plus something equals 90, and you figured out that that missing part was 15?
Yeah.
Okay, very good. Anybody else do that differently? What did you do to figure that out, Scotty?
Minus 90 from 75.
Okay, 90 minus 75. Brayley, what did you do?
I just needed to tell you something. This is a cup full of stuff.
Yeah, I know. Anybody do something different besides adding up or subtracting? What'd you do?
You could do this, but I didn't.
Okay.
You could do 90 divided by 75, then you get your answer.
Wait,
No,
no.
you're not dividing it. We know the total is 90,
You can
and
do.
we've got 75 of that taken by angle LMP. So I could either subtract to find the missing part, or I could add up like Cash did. Either one of those 2 strategies would work.
I didn't read the 90 degrees thing, and so I put 15 or 25 because I thought it was going to 100.
Yeah, you
Yeah.
gotta make sure that you read all of it. All right, next we have a triangle. We've got to identify the type of triangle, and remember there's always 2 ways that we can classify triangles. One is by
They're angles.
the angles, and the other is by the
Points.
sides.
Yeah.
The sides. All right, so let's look at the angles first. What 3 types of angles are there?
Options.
Obtuse and isosceles. All right.
Right, so there's 3 different types of angles. It could be a right angle, acute angles, and obtuse angles. So remember with triangles, all 3 of the angles have to add up to 180 degrees. So if you have 1 right angle in a triangle, what kind of triangle is it?
Right triangle.
A right triangle. If you have 1 obtuse angle in the triangle, what kind of triangle is it?
Obtuse.
Obtuse. And if you have all three of your angles are acute, then what type of triangle would it be? Acute. So looking at the three angles, do you see a right angle, an obtuse angle, or three acute angles, Harper?
I don't see a right angle or an acute angle. So
You don't see a right angle?
I see one.
Owen, what do you see?
I'm still not very good with these.
Do you see a right angle? If I look at these three angles, are any of those three angles right angles?
No.
What is a right angle?
90
90 degrees. And what does 90 degrees make?
Like a regular
right-
wall
right
angle.
triangle.
Yeah, like a corner, right?
Yeah.
Okay, do you see anything that makes a 90-degree angle or a corner? Yes. Right here, this top angle is a 90-degree angle. So if I have a 90-degree angle, then I know this is going to be what kind of triangle?
Right.
A right triangle. There's one of our classifications. So we've taken care of the angles. We know it's a right triangle because I have a right angle right here. So now I need to classify it by the sides. Equilateral means that all sides are
Equal.
equal. Are all sides equal?
No.
Two of them.
Alright. Isosceles says that 2 of my sides are equal.
Yes.
Do I have 2 equal sides?
Yes.
I'm hearing some no's and I'm hearing some yeses. Let's measure. Okay.
That one's straight, but the other one isn't.
Goes to about here. That's how long the top is.
No, it's not.
Not quite. It's close, but it's not quite the same.
So that would be.
And then if I go to this one, that's definitely not the same.
That would be.
So is it an isosceles triangle?
The bottom one and the top one look exactly the same size.
They're close, but not quite. So this has to be a scalene triangle, which means that there are no sides the same length. So it's a right scalene triangle.
I got it right. I don't know if I'm right or not. That's funny.
Okay. Here we go. Here is our last question. Next to last question. Max bought 6 4-packs of pens and 5 3-packs of pens. How many writing utensils did he buy? Scotty, how did you do that one?
I did. First, I figured out what was the equal to 6 times 4 and 5 times 3.
Okay, so why did you do 6 times 4 and 5 times 3? What told you that's what you had to do?
It says on there he bought 6 packs times 4
Mm-hmm.
and 5 with 3.
Very good. So we would have to multiply 6 times 4 to figure out how many pens were in the 4 packs. And then 5 times 3 to figure out how many pens there were in the 3 packs. Okay, so you did 6 times 4, which was
4 was
24.
Yeah.
And then 5 times 3 is
15.
15.
And then E and F is both of them.
Okay.
And then these them added together.
Okay, so if I add 24 plus 15, then I would get 39. Mm-hmm. So he bought how many writing utensils? 39.
Miss Wheatley, I surprisingly got all that correct.
Very good.
I got that one wrong.
Because it looks very hard at first.
I got that one wrong.
But it's actually
Okay, hold. There's more than one person talking at a time, and I can understand you all at the same time. Are you finished, Olivia?
Yes.
Okay. Yes, sir.
I knew it was 39, but when I scrolled over, I didn't see it 39, so then I clicked 49.
That's right.
Yeah, but then when I
39's
scrolled
over
over,
there.
I looked at it and I saw 39.
Okay. Yep. It's the very last option that you had.
Yeah.
All right. Questions on that one?
No.
Okay. It looks like a lot, but is it really?
No.
No.
I got everything
Okay.
right except for the last
All
one.
right. Let's look at number 5. This is our last problem.
I got this one.
Which model best represents the answer to this problem? 4 times 4/5. Before we answer that, let's take a minute to think about 4 times 4/5. So I'm doing 4/5 4 times. How could I rewrite that as an addition sentence? Olivia, how could I rewrite that as addition?
1/5 and 1/5.
I have 4/5
Well, 2.
4 times. So how would I rewrite that as repeated addition?
You could do 4/5 plus 4/5 plus 4/5 plus 4/5.
Exactly. I could do 4/5 plus 4/5 plus 4/5 plus 4/5. That's the same thing, isn't it?
Yes.
Okay. I have the same denominator. So all I have to do is add all those 4s, and what is that?
16.
16.
Fifths.
16 fifths. Okay, so if I were multiplying a whole number times a fraction, what two numbers am I multiplying together? Does my denominator change?
No.
No, I still have, if I'm multiplying a whole number times a fraction, my denominator is going to stay the same, and I just have to multiply my whole number times the numerator. So 4 wholes times 4 parts is 16, and they're still fifth size pieces. Okay, so I would have 16 fifths. Now we need to make that into a mixed number. How many, if I take 16 fifths, how many fifth size pieces does it take to make a whole? 5. How many 5s are there in 16?
3.
3. 5, 10, 15. So that would be 3 wholes. And how many would I have left?
1.
1 what?
1/5.
1/5. So I need to find the model that shows 3 wholes and 1/5 with none of them being crossed out because I'm not taking anything away. So what would that be, Christopher?
Option 4.
Option 4 is correct.
I looked at option 2 because I saw that it had there's 3, and I counted it. I was like, it needs one more. Then I looked down and
And saw
I
that.
saw that one.
That's
Very good. All right, questions on those?
No, ma'am.
All right, good job.